All right, my phone cut out on me again. Nothing like technology to force me to clean up my life, or my phone at least. 64 gigs of data and I still ran out of space. Right, so I cleaned up some of the stuff, so hopefully it doesn't cut out again. So this is the third video, continuing on from the original video of polymers. So let's take a look at this exam question. So it says alanine, serine, and prolene are alpha amino acids. So this is a question based on amino acids. So I've added a few notes. A question like this. It is nice, at least for myself, to change the display formula in, or sorry, that structure formula into a display formula, just so you can see where the bonds are. Particularly if this is going to be a polymer question, it helps to see where the linkage will end up happening. Okay, so I've done that. So that's our alanine, where you have the nitrogen, that carbon, CH3 bound to that one carbon as well as one hydrogen, and then your carboxylic acid functional group. And then serine, you have your amine, and then your carbon with a hydrogen, so carbon with a hydrogen, and then your CH2OH bound to that same carbon, and then your carboxylic acid functional group. So notice, if we think back to the original video when I talked about amino acids, this here in that generic structure that I showed would be the R group. So serine has a CH2OH, whereas alanine has a CH3. All right, so the question, alanine and serine react together to form two different dipeptides. So we are forming a protein, but this is not a long chain protein. We're told specifically it's a dipeptide, so it's going to be made up of two monomers. So we will have an actual end to our little polymer, or because it's actually less than 3 or 4 amino acids, it's actually just called a dipeptide. So draw the structure of the two dipeptides that can form when alanine and serine react together. So if we look at the structures here, we can see that with our carboxylic acid group, that OH can leave and bind with this amine, so that nitrogen where one of the hydrogens leaves. So we can have a linkage here. Or we have a carboxylic acid group here where that OH can leave, and our linkage could actually be between this nitrogen, or this carbon, and that N nitrogen. So we will have two different products because those different linkages will result in different dipeptides. So let's start first off, if that OH group is leaving, and we're going to have the linkage between that carbon and this nitrogen, and draw the structure. So we have our H2N, C with the CH3, hydrogen down below, carbon double bond to oxygen. Now the OH group from the alanine will have left to form water, and on our serine we're going to form the linkage between that nitrogen. One of the hydrogens have left to bind with that OH to form the water. We're still left with another, and then we have CH2OH. There's hydrogen there, and then we still have that carboxylic acid group. Okay, so like I was saying, in a polymer, if this was a repeating unit, that OH group wouldn't be there. We'd just be left with that open bond to say the chain continues. But this is not a continuing chain, it is just a dipeptide. All right, so now our other product is if that OH group were to leave. So I'm going to start by drawing the serine. All right, so that OH group is left, and that carbon's now going to bind to this nitrogen over here. and that will still have one hydrogen. And then that carboxylic acid group. There we go. Okay, so it is worth just taking those slowly. Okay, dipeptide, we're forming a peptide bond. Remember, peptide is the same as an amide bond or an amide link. So that's your amide link formed between your alanine and your serine. And on the other one, this is our amide formed between that serine and that's alanine. All right, so this continues. The next part of the question says the isoelectric points of alanine and serine are shown below. So alanine, the isoelectric point is a pH of 6, and serine a pH of 5.6. Okay, so I started writing some notes on this already, but I'll talk through it anyways. All right, so the question, draw the structure of the ions formed at the following pHs. So the structure of the alanine ion at a pH of 6. So if we check the isoelectric point, that is 6. So this diagram will be our pH at the isoelectric point. So we should be thinking about forming a Zwitter ion there, okay, or drawing a Zwitter ion. The serine structure, or the structure of serine ion at a pH 10. Now 10 is greater than 5.6, so here we're pH greater than the isoelectric point. So if we think back to that video when I talked about amino acids, so that's in that original polymer video, the Zwitter ion, we're going to have an NH3 plus and carboxylic acid. That functional group is going to become CO minus. So if we draw that for alanine, I'm going to move this so that we can see what alanine looks like again. So NH3 plus and the CO minus. Okay, so that's that ion of alanine at pH of 6. And the serine, when we are a pH greater than the isoelectric point, that's when we're going to have the COO minus. So the H2N stays like that. I'm going to reiterate, be careful with your bonds. You don't want it to be ambiguous. They want it, like this actually is a little bit ambiguous. That hydrogen's drawn really far away. Okay, so you want nice clear bonds from one atom to another. All right, so that's our serine ion at a pH of 10, where we have that negative charge. Okay, so the last bit of the question is Prolene can polymerize to form polyprolene. Draw the structure of the repeat unit of polyprolene. Okay, so we look at Prolene there. Our carboxylic acid, that's going to be continuing of the chain, and that NH group will also be a continuing of the chain. So if we go ahead and draw that, I'm going to start with the nitrogen. Here we go. Where we have the carbon double bond, the OH group will have left, so that's where we're going to continue our chain, and that H will leave and we'll continue our chain there as well. So that's our single repeating unit for polyprolene. question done. I think I only have a couple more. If you're tired of these and they're not helpful, by all means, just turn the video off, but hopefully they're helpful and helping you think through how to tackle these questions. All right, so this is just part of a question. I chose the part that was relevant to this video, so the polymers. So let's take a look. So the chemist synthesizes compound M, which can undergo both addition and condensation polymerization. Okay, so we know it can do this and that. So we can make some notes. Double bond, that's where we're going to have addition. Carboxylic acid, that, and that alcohol is where we'll have condensation. Okay, so just making some notes so that we have a start to tackle any questions that might come about. All right, so draw the repeat unit of the addition polymer formed by M. So we're looking at this double bond. I personally would like to shift this a little bit, so because we're going to have a carbon, and that's where we're going to have our continuation. I'm going to show that, and then I'm going to add in the other parts. So this will still be attached. Okay, but it's not changing because it's the double bond that's breaking for the addition polymerization. And same thing, none of this is changing. So to that carbon, we still have that phenyl group, or phenol. So we can draw and then from that carbon 1, 2, from that carbon 1, 2, that's where our OH is. Okay, so that is our repeating unit for the additional polymerization. The next one, draw 2 repeating units for condensation. So that's when we're going to have the OH leaving and that H leaving. And we don't want to just draw the one repeating unit. So I'm going to start with the one repeating unit where we have our O. That's not going to change. This carboxylic acid is now going to, that's one repeating unit, sorry, but we want 2 repeating units, so we're going to have to go back and draw the molecule again. So this carbon will end up binding to one of those oxygens. Okay, and let's just draw it again. And then this time around, that's not going to connect. Oh, let's actually draw that as a C and actually do that as a dotted line, because doing a skeletal diagram, if it's a solid line, they're going to assume there's a terminal carbon, right? So be careful with that. We're going to do a dotted line because this basically is a skeletal diagram and we don't want them to think that we think there's a CH3 at the end. Okay, so watch out for that. And then we have our dotted line over there too to say the chain's going to continue there and it's going to continue there, but we have our this is a ester link within our 2 repeating units. All right, last question. So this is a bit of a combination of a synthesis and then also looking at polymers. Okay, so compound 9 is used in the synthesis of polymer 1, as shown in the flowchart below. Complete the flowchart by drawing the structure of the acyl chloride and 2 repeating units of polymer 1, and stating the formula of the reagents required for the first stage. All right, we're going to make an acyl chloride. So I'm going to go back to that, my map. Hopefully you've drawn it out. Let's take a look at it there. Acyl chloride. And let's look at the question again. We're making an acyl chloride. Okay, and if you look at the functionals, if we identify the functional groups here, we have a phenol and we have a carboxylic acid. So if we're making the acyl chloride, well, we only have one arrow pointing there, which is from our carboxylic acid, using SOCl2. So our formula for the reagent is SOCl2 there. Okay, and then if we quickly look at what happens if we look at our mind map again, your carboxylic acid, the OH comes off and is replaced by a Cl. So that's what we're gonna do here. And that OH becomes a Cl. So that's our acyl chloride. And now 2 repeating units. So this is an example where we have, with our ester link that we're going to form, the H is going to come off. We don't have an OH to come off though there. We have a Cl. So that H and that Cl, this is where the small molecule that forms will be HCl instead of water. So now we know where our link is going to be. Let's draw this out. So the O will be the end of our link. C, the Cl is left. It's going to bind with the O of another one of these monomers. And that's, sorry, that was 1 repeating unit. We're drawing the second now. And that will be left open because it's going to continue on. 2 repeating units, and we have clearly shown our ester link within that polymer repeat unit. All right, hopefully that was helpful. Not long now. Your exam's in June, so 2-3 weeks, and then you'll be done. So remember, you are awesome and you totally got this. Good luck.